Let's consider a beam. When a beam is loaded, internal forces develop in it to maintain the equilibrium. These internal forces have two components. If we consider a cross-section of the beam after loading, we can mark forces oriented in the vertical direction due to applied external force. These forces are generated in everywhere in the beam in vertical direction, and it is called a shear force. And other internal forces are normal forces, which are oriented along the axis of the beam. If the beam is sagging, top of the beam will get shorter and the normal forces in the top of the beam will be compressive, the bottom of the beam will get longer. And so the normal forces in the bottom of the beam will be tensile. Each of tensile normal forces has a corresponding compressive force which is equal in magnitude but opposite in direction. As such, these forces do not produce a net normal force, but they produce a moment. It is called as a bending moment. We can conveniently represent the internal forces acting on the beam cross-section using just two resultants. One shear force, which is a resultant of vertical internal forces, and other one bending moment, which is a resultant of the normal internal forces. This is the very common way of representing the internal forces within a beam. These resultant shear forces and bending moments will depend on the loads acting on the beam and the way in which beam is supported.